All right, here we go. Firefighter is what we're looking at. He says here, students will learn how to use square roots to solve the sides of a right triangle. Most of you guys should already know how to do this. All we're talking here is Pythagorean theorem, a squared plus b squared equals c squared. So it should be fairly easy here today. All right, so if we take a look at the top of your paper, it says that there's a fire truck that can get 12 feet from the base of a burning building. The extension ladder is used to reach the upper floors. Because the ladder can be extended to various lengths, it can reach higher and higher up the side of the building. Answer the question below to describe the relationship between these two quantities. All right, so again, the fire truck is 12 feet away from the burning building. Number one says, if the ladder were to be extended 13 feet, how far above the truck can the ladder reach on the building? So notice here it does say to draw a triangle and explain your work on how you came up with your answer. So what we're going to do is we're going to take a close look at what we're dealing with. Here's what we're dealing with. We've got this fire truck. It's 12 feet away from the building. We've got this extension ladder and the height of the thing here from the base or the height of the truck. Let me move this out of the way. We are dealing with a right triangle. We know that the distance from the truck to the building is 12 feet, so I'm going to go ahead and label that right now. Notice they do tell us that the extension ladder is extended to 13 feet, so this part right here is 13 feet. What we're going to be looking for is this right here. How far above the truck can the ladder reach? That's what we're looking for. So, in order to do this, obviously you can see here we are working with a right triangle. And within this right triangle, we've got a side dismissing. And anytime we got a side dismissing on a right triangle, we can use that Pythagorean theorem. A squared plus b squared equals c squared. Now you do have to be careful because two of these sides represent the legs. The other side represents the hypotenuse. So let's make sure we get the numbers in the right spot. A. What is our A? What's one of our legs? 12. So let's go ahead and fill that in. 12 is one of our legs. B. What's our other leg? We have no idea. It's question mark. Now, we're not going to use question mark. Up here, they're using a Y to represent that height, so I'm going to use the same thing. I'm going to use Y. So Y is going to go right here. C. C is the hypotenuse, or the extension ladder. And that extension ladder right now is extended to 13 feet. So I'm going to put in 13 for my C. So I've got 12 squared plus y squared equals 13 squared. This is what I need to solve. As I mentioned earlier, you guys have done this before. The first thing we're going to do is square these two numbers. So 12 squared is 144. 13 squared is 169. What's next? Subtract the two. There you go. Subtract 144. So if we subtract 144, we get y squared is equal to 25. That's not the answer though. You got one last step. Square root. The opposite of squaring something is to take the square root. So let me go ahead and take the square root here. The square root of 25 is 5. Which means this over here, how far above the truck can the ladder reach? Well, in this case, it's going to be 5 feet. 5 feet because we've extended that ladder to 13 feet. So the answer to number one should be 5 feet. Pretty easy. Number two is basically like number one. Number two says, what height can be reached above the truck if the ladder is extended to a length of 15 feet? Well, again, let's draw ourselves a right triangle. The truck is still 12 feet away from the building, so this is still 12. This time the ladder is extended to 15 feet, so this over here is 15 feet. And we're still looking for the height that we can reach above the truck. So we're still looking for y. So out to the side, let's show our work. A squared plus b squared equals c squared. A is the leg, which is our 12. B is another leg, which is going to be our y. And c is our hypotenuse, which in this case is 15. So now we're working with 12 squared plus y squared equals 15 squared. So all that work I did on number one, I'm just going to repeat that work again. So we're going to start by squaring the two numbers. So we're going to have 144 and 225. Then what we did was we subtracted. So let's do the same thing again. Let's subtract 144. 81. So we get y squared was equal to what again? 81. 81. But that's not the answer just yet. The opposite of squaring something is to take the square root. And if I take the square root of 81, that's going to leave me with a 9. Therefore, the height that we can reach above the truck is going to be 9 feet if we were to extend this ladder 15 feet. Okay, so 9 feet is the answer to number 2. Pretty easy. Number 3, it says, in this problem, we're going to let x represent the length in feet to which the ladder can be extended. We're going to let y equal the height in feet that it can reach above the truck. And we're going to complete the table and graph this relationship. So we're going to take each of these right here, which are going to represent the length of the ladder, and we're going to find out how high above the truck we would be. So let's start with the 12. If we were to extend the ladder 12 feet, how high above the truck are we going to end up with? Well, it's the same work that we did on number 1 and number 2. We're still using a squared plus b squared equals c squared. A is still going to be the distance from the truck to the building, which is 12 feet. We're still looking for the height, which we said we're using y. So let's use the same thing again, y. C is the hypotenuse, or in our case, the length of the ladder. And the first one we're looking at here is 12. So if I put 12 over here, I end up with the equation 12 squared plus y squared equals 12 squared. So let's see what we get. 12 squared, that's 144. 12 squared, that's 144. Subtract 144 from the other 144, and we get 0. Anybody know what the square root of 0 is? Square root of 0 is 0. So if we come over here in the table, we should have a 0 right next to our 12. So what we're saying here is if the ladder is extended 12 feet, the height above the truck will be 0 feet. Can somebody explain that to me? It'd be like 12, right? Yeah. If we extend this ladder 12 feet, all we're going to do is basically touch the building. That's all we're doing. And we're not going any higher than the height of the truck. It's pretty much level. What if the ladder was extended 13 feet? 5. We already did that one. That was number 1. What if we were to extend the ladder 15 feet? 9. We did that one. That was number 2. 20, 25, 30. 37. I want you to do those on your own, see what you come up with, and fill out that table for me. Once you fill out the table, I want you to take these points, these ordered pairs, and plot them on the graph, and then we'll take a look at them. All right? So do 20, 25, 30, and 37 for me using Pythagorean theorem. A squared plus b squared. But, good question. Do we want to connect the dots? No. Do not connect the dots. I will give you a little heads up. When you do 25 and 30, 25 and 30 will result in some decimals, and that's okay. Just go ahead and round that decimal to the tenths for one decimal place. That's all I need. 25 and 30 will be decimals. Yeah. Turn around, go one decimal. Okay, looks like the majority of you have got your table filled out or pretty close to getting it filled out. So let's take a look at the numbers you came up with. If we were to extend the ladder 20 feet, how high above the truck are we going to be? 16. If we extend the ladder 25 feet, what's the height? 21.9. If we extend the ladder 30 feet, how high above the ladder? What was it? 27.5. There you go. 27.5. And the last one, if we extend the ladder 37 feet, that would put us how high above the truck? 35. Okay, now that we've got the table filled out, we're going to go ahead and plot these points. Now, be careful over here on the x-axis. Notice they are counting by 2. On the y-axis, notice they are counting by 5. So we're going to start by plotting the ordered pair 12, 0, which would put it right about here. There's 12, 0. Now we're looking for 13, 5. 13, 5 is going to be right about here. 15, 9 is the next one we're looking for, and 15, 9 is going to be almost up to 10 there. 20, 16, here's the 20. 16 is just above that line. 25, here's 25. 21.9, right about somewhere there. 30, and 27.5, here's 30, 27, about a little higher, 27.5, and finally 37. 37 right about here, 35, and somewhere about there. All right, so go ahead and make sure you got all your points plotted. Now that you got your points plotted, let's go ahead and take a look at the next page. Over on the next page. Over on the next page, it says that a function to model the relationship between the length of the ladder, which is our x, and the height that it can extend above the truck is f of x equals the square root of x squared minus 144. Now, before they ask, where did this come from? How the heck did they come up with the equation f of x equals the square root of x squared minus 144? Can anybody tell me where this came from? Miles. Where did that equation come from? What? It's coming from this thing right here. Now let's be more specific. How are we going from that to that? Well, let's think about it. What was our A? The distance from the truck to the building was always the same, right? It was always 12 feet. That was, and it really doesn't matter as long as it's one of the legs. B was the other leg, which represented the height above the truck, which was, I think they were using Y. C was the length of the extension ladder, which in our case, we're calling that X. So we're using A squared plus B squared equals C squared. 12 is the distance from the truck to the building. This Y right here was representing the height, and X was representing the length of the extension ladder. So we're getting closer to explaining how we got from this thing to that thing right there. So let's show it work. How do we go from this to this? Well, what do we do first? What do we do first on all those that we did together? We did 1, 2, and 3. First, we squared the number. So 12 squared is 144. That was the first thing we did. We squared the number. What did we do after we squared the number? Subtracted, didn't we? We subtracted the 144 from whatever was over here, which would give me y squared equals x squared minus 144. What was the last step that we did? Square root. Square root. Square root both sides, which is going to leave us with y equals the square root of x squared minus 144. That's how they came up with that thing over there. From a squared plus b squared equals c squared. All right, that was number 4. Number 5, we're going to be graphing this thing here, and in order to graph it, we need to make sure we have our window set up correctly. So everybody go to your calculator, go to window for me. Go to window. What we're going to do is we're going to graph that square root of x squared minus 144. And it's basically going to look like number 3. So we need to make sure we make our window big enough for us to actually see this graph. So everybody turn to number 3 for me real quick. Number 3, we're given a table of values, which is the same values that we use in our graph. So I'm going to start with the x's. The x minimum. What's the smallest x value we're going to need in order to show this graph here? Okay. Well, let me ask you this way. What do the x's represent? The extinction ladder. So the length of the extinction ladder. Are we going to need negative numbers? No, we're only going to need positive numbers. We're only going to extend it a positive number. So we're going to start with 0. We don't need any negative numbers. The x maximum. Again, look at your table on number 3. What was the largest x value we had in our table? It was 30. No, we're looking at the x value. Make sure you're looking at the x. 37. 37 was the largest x value. But I always like to make my window just a little bit bigger than that. So I'm going to make it 40. Now, if I'm going from 0 to 40, what kind of scale are we going to use? If we count by 1s, that means we're going to have a lot of those little marks in between 0 and 40. So we can do 2s, we can do 5s, we can do 10s, we can do anything we want. What do you suggest? 2s, well, that would be better than 1, but I could go with something more like 5 or 10. We'll go ahead and use 5. Okay, so that takes care of the x's. Now let's take a look at the y values. Remember, the y values are representing the height above the truck. Are we going to have any negative numbers if we're talking about height above the truck? No. So where are we going to start at? 0. So look at the y values on your table there. What is the largest y value we have? 35. But, again, I like to make it a little bit bigger than that, so we'll go ahead and round it to 4, just like the other. And if we're going from 0 to 40, what kind of scale are we going to use? Well, let's go ahead and use the same scale, 5. So make sure you have it written down on your paper, but also make sure you have it on your calculator. If you don't have it on your calculator yet, go ahead and do that for me. Okay, number 6 says, type this function into your calculator. So everybody go to y equals. And what I need you to do is in y equals, you're going to type in that square root of x squared minus 144. So go ahead and type that in for me. Once you got it typed in, the first thing I want you to do is go ahead and look at the graph. And that graph should look very similar to what we had on the very first page. Look at number 3. Notice the dots that we made earlier should pretty much follow that same pattern that you see on your calculator. We all agree on that? Yes. Okay. Now what I want you to do is go to your table. Go to your table. Right now we're on number 6 here. Now on the board here it says C and D, but I think on your paper it says A and B. Is that right? No, it says C. It says C and D? All right, it should have been A and B. Go ahead and scratch that out. It should be A and B. All right, so again, what we're doing is we're looking at 5, 6, 7, and 8 in our table, and we're going to write down what we see next to that 5, 6, 7, and 8. So what do y'all see next to 5, 6, 7? 0, 0, 0? Error. So write that down for me. Right next to 5, you see error. Next to 6, you see error. Same thing for the other 2. So in number 6, part A, they ask us, explain what this means in context of the problem. Why are we seeing an error next to 5, 6, 7, and 8?
So there's nothing that. It has to be 12 feet away from the building.
Okay, we know that the truck is 12 feet away from the building, correct? So think about it, guys. If we were to extend the ladder
Anything less than
5 feet,
yeah.
what's going to happen if we extend this ladder 5 feet? Are we going to reach the building? What if we extend it 6 feet? Are we going to reach the building? No. 7 feet. Are we going to reach the building? No. As a matter of fact, look at your table, guys. What do you see right next to 9? Error. What do you see next to 10? Error. What do you see next to 11?
Error.
What do you see next to 12?
0.
0. So notice you keep getting there until you get to 12. And why is that? Because it's not until 12 that we actually reach the building. Okay? So right here on part A, explain what this means in context of the problem. The reason we're getting an error is because we're not going to reach the building. So when we extend the ladder 5, 6, 7, and 8 feet, we do not reach the building. when we extend the ladder 5, 6, 7, and 8 feet, we cannot reach the building. All right, so I helped you out with part A. Now you're going to answer part B for me on your own without saying anything out loud. I want you to think about this. Part B is basically like A. This time they ask you, what does that mean in terms of the numbers? Your calculator has no clue that we're talking about an extension ladder trying to reach a building. So why is it giving us an error? I want you to write it down on your paper. Do not say anything out loud. Why do we get an error next to 5, 6, 7, and 8? When the calculator has no idea that we're talking about extension ladders and trying to reach a building. Write it down. Think about it. Make sure you go into a little more detail than because. I need more than because. All right, let's see what you guys came up with. B, again, what does this mean in terms of the numbers? Why are we getting the error for 5, 6, 7, and 8 on our calculator? What's that? What's imaginary?
Because it's squaring.
I think we're on. What?
Because it's squaring.
Because we're squaring. Well, look at it this way, guys. Remember the equation we were working with was this right here? That's what we're working with. So think about it. That x, if I replace that x with a 5, 6, 7, or 8, what's going to end up happening?
You're going to have a lesser number and you can't square it.
There you go. Let's just take the 5, for example. If I do 5 squared minus 144, what's 5 squared? 25. And what's 25 minus 144? A negative number. And what's going to happen when you take the square root of a negative number? It's going to say error. So the reason you're getting error there is because you're trying to take the square root of negative numbers. So write that down for me on B if you haven't done so already. The reason we're getting an error is because we're trying to take the square root of negative numbers. Let me ask you a trick question. I'm giving you a heads up. It's a trick question. Can we take the square root of negative numbers?
Well, you can, but you just get an
Yes,
imaginary
you
number.
can. There you go. That's what I was. Yes, you can take the square root of negative numbers. It's just not a real number or a real answer. It's going to be what again? An imaginary. Okay, so yes, we can take the square root. It's just not real. It's imaginary. As a matter of fact, that's why when you put this in your calculator, it says non-real answer. Non-real. Okay, we got 3 more to look at here. Number 7 says, what would you say is the domain of that function? Somebody give me the domain of that function. Well, we know domain is x. I'll give you that much. What is the domain? What are the x values?
All greater than or equal to x.
X is greater than 5.
0. X is greater
X is greater than.
I'll give you the greater than or equal to part. Greater than or equal to, well, yes, you can do it the other way. X is greater than or equal to 12. Y'all remember when we did the table, we kept getting an error until we got to what number? 12. It wasn't until after 12 that we started seeing the y value. So the x values have to be greater than or equal to 12. What about the range, the y values? What kind of y values?
Greater than or equal to 0.
Y is greater than or equal to 0. There you go. Y values are anything greater than 0. Talking about height. And the last one, number 9, how do the numeric domain and range relate to the original word problem? So let's get a little more detail here. When we say the x values are greater than or equal to 12, what are we really saying?
That
The ladder
the
is
firefighter 12 feet over after 12 feet.
All right, so the extension ladder has to be extended at least 12 feet. Right? In order to reach the building, we've got to extend it at least 12 feet. So write that down for me. That's part of our answer. We've got to extend this ladder at least 12 feet. Otherwise, we wouldn't be reaching the building. Let's do the same thing with the y values. When we say the y values have to be greater than or equal to 0, what are we really saying? There you go. Basically, we're saying that the height has to be right. The truck's height or height has to be some positive value. So the height is a positive value. There is no such thing as somebody being in here negative 5 feet tall, correct? Height, when we're talking height, it's got to be a positive value.